Chapter 3 notes. Today we're going to start with exponents and the rules of exponents. If you look in the examples in the upper left-hand corner here, we have x to the third. This is just a reminder that that means x times x times x. Okay, so an exponent is just a way to show repeated multiplication in a shorter way. 2 to the fifth, of course, would mean 2 times 2 times 2 times 2 times 2, 5 times. And a lot of times we'll finish that by saying that's 32. So for question number 3, we have 3 4s, so it'd be 4 to the third. And then we have 1, 2, 3, 4, 5, 6 y's. So we have 4 to the third, y to the sixth. Okay, so exponents are a way to write repeated multiplication in a shorter format. Moving over to the right, there'll be some times when we're asked to multiply terms with exponents. And for multiplying powers, the rule is pretty simple. You must have the same base on each exponent, so that's very important. Okay, that if we're going to multiply, it would have to be, in this case, both bases have an x. When that's the case, the shortcut to doing this is to simply add the exponents, but keep the same base. So the answer would be x to the m plus n. And I think there's an easy way to demonstrate this. If we had x squared times x to the third, okay, x squared is really 2 x's. And x to the third is 3 x's. Altogether, I have 5 x's. That's why it's x to the fifth. And of course, the shortcut is to add those two together. So x to the fifth times x to the 24th, my first example here, would be x to the 29th. For example 2, I have x's and y's being multiplied together. So first, only exponents with the same base can be multiplied. So I can do x to the third times x to the fifth. And by my shortcut, I would add 3 plus 5, be x to the 8th. And I have to treat the y's separately because that's a different base. Okay, it's a different letter. So y to the second times y to the 10th. My rule is I add those together, so it'd be y to the 12th. On the third example, you'll notice that there are numbers in front of the bases. These are called coefficients. Okay, they do not have an exponent with them. So when that's the case, and I just have numbers, we can multiply those numbers together because that's what we're doing. We're multiplying, so 2 times 3 is 6. And then I will handle the terms with the exponents, so like x to the 9th and x to the 6th. I can combine those because they have the same base. So 9 plus 6 would be 15. So I have x to the 15th. And then I have y squared, or y to the second. And notice the second term doesn't have a y. So I have nothing to multiply it by, so it would just stay y to the second. This is a pretty common mistake kids make in algebra, is that they see these numbers in front, and we're working on adding the exponents, so they think, oh, I should add those together. So they do 2 plus 3 and get 5 instead of 6. You have to remember that the general operation here is that we are multiplying 2 terms together. So those coefficients or numbers out front, those just get multiplied together. We only add the exponents. Okay, that's important. 4 is a very similar question to 3. It's just written in a different format. On 3, there was just a dot between the 2 terms, which of course means multiply. For questions like 4, when they use parentheses like that to separate the 2 terms, that just means multiply too. So 3 and 4 are just 2 ways of writing the same problem. So the answer would be 2 times 3 is 6. I've got 15 x's and just y squared. So 3 and 4 are basically the same question, just written in different format. We can also divide powers. So if you look down in the bottom left-hand corner of these notes, I have x to the m over x to the n. That's division. And notice they have the same base again, because this rule also requires that to do this, you need the same base. And you can probably guess, since multiplying powers, we added the exponents. When we divide powers, we subtract. And as an easy example of this, let's say I had x to the 5th over x to the 3rd. X to the 5th means I have 5 x's, as we know. And x to the 3rd means we have 3. Well, anytime I have x over x, that cancels out or becomes 1. So 3 x's on the bottom will cancel with 3 of the x's on top and leaves me with 2, which of course is written as x squared. But the shortcut would have been to take the 5 and subtract the 3. That also gets me the 2. So for the first one, x to the 40th over x to the 15th, they have the same base, so I would do 40 minus 15, which is 25. Example number 2, notice here I have coefficients again. I have numbers that aren't part of the exponents. I have the 10 and the 5. We don't subtract those, we divide them, because this is a division problem. So 10 divided by 5 would be 2. And then I have x to the 12th over x to the 6th. Here's where I would subtract the exponents. So 12 minus 6 would be 6. So when you're dividing, just remember you subtract the exponents. And again, they must have the same base. So for example, if I had this question, x to the 5th over y squared, there's nothing I could do to that problem because they do not have the same base. Okay? They need to have the same letter. To the right, bottom corner, says power of a power. This is the last rule we're going to learn today. So this problem looks like this. I'll do the example first. If I had x to the 3rd, and then parentheses, and then squaring that. Well, we know that squared means I have 2 of what's being squared. So I have this, x to the 3rd times x to the 3rd. And I have a rule for that, right? Multiplying powers, I just add the exponents, so that'd be x to the 6th. I bet you can see the shortcut if you look. How could I get 6 from 3 and 2? Well, I could multiply them. So x to the m to the nth power would just be x to the m times n. So I would multiply the powers together. So number 1, x to the 4th to the 5th power, I would multiply 4 times 5 and get 20. Now, example 2, I have 2x to the 3rd, y to the 2nd, and all of that in parentheses to the 4th power. So I'm going to multiply every exponent in that little. So I'm going to multiply every exponent in this expression to the times 4. So it'd be x to the 12th, y to the 8th, and then I also have that 2 up front. And I have to raise that 2 to the 4th power as well. So it'd be 2 to the 4th, x to the 12th, y to the 8th. And 2 to the 4th is just 16. So that would be my final answer. This one behaves kind of like this. That 4 is going to be is going to go to every term in those parentheses. So the same thing on 3, that 2 goes to everything in parentheses, so it'd be 3 squared, x to the 4th, because I'm going to take 2 times 2, and y to the 6th, because I'm going to take 2 times 3. And then 3 squared, of course, is 3 times 3, which is 9, so it'd be 9x to the 4th, y to the 6th. So as you're going through the homework, feel free to refer to these notes if you forget or get lost or can't remember what to do.